Okay, recording start.
Okay. So thank you so much for joining. This is another series of webinars being organized by the African Digital Leadership and Innovation Network, and in collaboration with Division X in Egypt. We present to you Unlocking AI Vision Computer Innovation to Reinforce Agricultural Farm Sustainability in Africa. This is a very inspiring topic, and I'm sure with my esteemed speakers, we are here to share with you the innovation expectations in the future and in the present. And at the same time, what are the expectations of using this technology to support the value chain, especially the farm scenarios in Africa, in order to actualize climate intervention actions and to support smart monitoring of farms. And at the same time, we'll be hearing the different impacts and sustainability aspects from our speakers today. So thank you, our speakers, for joining us. And we have speakers from North Africa, from Egypt, from Ghana, from South Africa, and we really appreciate this. From Italy, our international partners joining us as well from Italy. We appreciate you, and we look forward to a very successful webinar session and a very informative session. And thank you so much for joining us. So my audience, you are welcome to join us as well. If you are joining us from anywhere in Africa and from Europe, from globally, you are also welcome. We welcome you to this session, and definitely we are very sure that the information we'll be sharing with you will be very, very informative. Thank you so much. And I start right now with the first speaker. Just a short introduction of yourself. Mahmoud Abdel Aziz, please, over to you. Just a short introduction. Thank you.
Okay, Becky, thank you, Keynes, for your intro, and thank you all for speakers and for attendees too. My name is Mahmoud Abdelaziz. I am founder and CEO at Division X, that is working in building AI computer vision solutions or infrastructure for different sectors through our no and low code tool Tuba.ai. This is just a short intro, so I can give you more details in my presentation. Thank you.
Thank you so much. I call on Katrina, please, over to you. Thank you.
Just a second, I will share my screen.
Just a short introduction. You don't need to share any screen yet. Just a brief introduction about yourself. Yes.
Okay. Sorry. Well, I'm Katarina Usnarovsky. I'm CEO of Software House, Italian software house. We have been working with computer vision and artificial intelligence since 2006. And we have been working a lot with precise agriculture and autonomous vehicles. So, well, today I'd like to present our solutions and our experience. And as we are experts on international level of AI, so I hope I will answer all the questions regarding possibilities and future steps in this field. Thank you.
Thank you so much, Katrina. And I call on Imam, please, Imam Ibiri, right? Thank you. Over to you, please.
Hello, everyone. I'm Dr. Iman. I'm from Tunisia. I'm proud to be with you. I'm the co-founder and the CEO of RoboCare. RoboCare is an agri-tech company that provides farmer recommendations on the best practices, what to do at the right time, this to improve their productivity. Our mission is to democratize the access of technology to all African farmers. So we start with crops, African crops, so that we help farmers to improve the productivity. Our data source, technically, our data source is satellite data, is drones, sensors. We have data vision of 4 types of data: satellites, drones, sensors, and the most important data, according to our experience and our use case, is the field data. So we get data from the field, from the farmers, from the agriculture consultancy, so that we help him to improve the farmer practices. So I'm there today to introduce to 2 real cases.
Thank you so much. Thank you so much. I call now on Ebenezer from Ghana. Thank you. Ebenezer, please.
All right, thank you. Can you hear me?
Yes, please. Yes, please.
Okay, I'm Ebenezer Kesiabi from Ghana. I'm a research fellow at the Earth Observation Research and Innovation Center. Basically, we are into deploying satellite technologies and weather information systems to farmers, to consultants, and to corporate institutions. So today I also try to introduce you to the things we do at the center, and maybe we discuss more on the future of AI to agriculture. Thank you so much.
Thank you for joining us. And I call now on Simeon from South Africa. Simeon, please. Thank you.
Good morning, everyone. My name is Simone Smith-Godfrey. I am from South Africa, and I'm an I-10 rank index researcher in the maritime industry, and I'm a Blue Economy scholar. I represent a number of organizations here today. First of all is the South African International Maritime Institute, where I act as a research associate. And then secondly is as the chief researcher at Maritime House. And then also as a member of a very brand new and exciting Chamber of Commerce that are aimed at the blue economy. So what I would be speaking to you today is into aquaculture and how it is part of agriculture, and what difference AI has made on the field of aquaculture, as well as the explosion in the consumption markets of aquaculture and the opportunity that it offers to Africa. Thank you very much.
Thank you, Simeon. Thank you so much. And now, it's okay. I'll be calling on Angie. Angie is also from Egypt. Angie, please, over to you. Your short introduction. Thank you.
Good morning, everybody. This is Inji Abdulwahab, Head of Exploration at UNDP Egypt Accelerator Lab and founder of Unica Research, a market research company. I'll be speaking with you today about our big data futures platform, Egypt's Horizon Scanner, and how it can support the agricultural ecosystem in navigating emerging signals of change, issues and trends, and how it can support their agility and quick response. Thank you.
Thank you so much. I call on Andriano. Please, over to you.
Yeah, so first of all, thank you for the meeting, for organizing this nice opportunity. I'm Adriano Mancini, Associate Professor at the Polytechnic University of Marche, Italy, and I'm working in computer science. And in particular, we are cooperating as university a lot with agronomists and companies in order to bring solutions to the farmers, especially for small-scale farming that we have in Italy and also in Europe. And today, I will try to show you some experience and some general topics that we have in Europe, but also that can be applied in Africa, because we have a lot of opportunities to share with all of you. So thanks for all, and enjoy the meeting. Yeah, thanks.
All right, thank you. And in no particular order, my co-moderator is not able to join us today because of an emergency. And thank you so much for your time. And we take now the first speaker, Mahmoud. Please, over to you. Let's take your presentation and the topic, especially the subtopic you would like to share with us. Thank you. Over to you, Mahmoud.
Okay, thank you, Kenneth. I will just will share my presentation right now. So you see it right now?
It's loading. Okay, it's coming up.
Okay, perfect. So I will talk more about what you are doing at Division X, and the facilitation that we can provide for agriculture sector and for service companies that work on agriculture sector too. Yeah. So we at Division X are empowering businesses to integrate AI vision seamlessly by reducing time and the cost of the development environment. How we can do this? So we can do this with by solving different problems like complex development process and the shortage of AI skilled talents and the lack of accessibility of easy tool to build your AI models, and also the data privacy concerns. So these are most of problems or challenges that facing anyone wanted to develop AI computer vision solution. And this inspired us to build Tuba, that is a one-stop platform to build AI vision applications seamlessly. It's one platform, so you can label your images or auto-label it, make a training, and also make a deployment, whatever deployment is on cloud or on edge. So we are offering Tuba as a SaaS platform, as a no-code platform, and then we can offering it also as a low-code SDKs or on-prem platform. And the last offering also is offering it as infrastructure as a service to provide a full customized pipeline based on our SDKs to enable you and your team, whatever this team is, domain experts or developers, to build their models quickly. So what is the advantage of it? It's zero line, of course. No need to write any code. Cloud agnostic, so it can be deployed on any cloud providers, Google Cloud, Microsoft Azure, or AWS, or others. Depending on AutoML technique, it's the concept of automation of machine learning models building, and also lastly, we are integrating large vision models, that is the sub from large language models for automatic labeling and also accelerating the training itself. And last one is the modular process, so you can use it as a modular based, so it can be labeling only, training only, deployment only, all them together. This is just a quick video demo to show it how it can work. This is loading. So you can create a project, and you can choose it as here. You can choose between labeling and training project. So just choosing between operation like classification or detection or segmentation according to your case. So then you can add your labels here. So everything is through GUI. After that, you can upload your images, and then you can go to the labeling process. The same process can be done automatically with the same, but here it's done manually. So you can go to each image and label it. Here we are using classes dataset to classify between eye and the shutter defects. And there's a classification labeling. If there's a detection or segmentation labeling, you just have tools in the side here to just make bounding boxes or polygon around the defects. After that, you can start a training or expose the labeling data set. In the training itself, you can choose between manual or automatic. Automatic, everything will be done by default. Manual just will choose different options here. It's a simple one. And then training is happening in the background. You can monitor it to see some graphs. And after it finished, you will receive an email that it is finished. After finished, you can go to the dashboard to just choose the model, and you can export. You can download the model itself, or you can make a prediction to just test if the model is working well or not as an inference option. And the idea here is, so as you, the idea of democratizing it, so as you, the owner of your data, so you are the owner also of your model, and this is the idea of Tuba concepts. Yeah. So we are reducing annotation time by 65%, depending on auto labeling. Also, now we are reducing the images per class, average 20 image per class for classification or detection or segmentation. Also, deployment is 96% faster than the traditional one of deployment. So it is just one click to deploy on the cloud or mobile or on the edge. So we are generate models for TensorRT, for example, for the NVIDIA Jetson, OpenVINO for Intel OpenVINO, or Onyx, or different model formats. And finally, we cutting the edge by job manager of SDKs. So we also provide SDKs for utilizing the using of GPUs. And the idea of infrastructure is, so we simplify the development itself environment, scalable infrastructure for your team and your workflow. Finally, we go to the agriculture application to see how this enabling technology and these platforms can be deployed or can be used to have different applications in the agriculture. I know that some of you already building a similar application like this, but I just will show it for you to make sense or to link between our technology and how it can be applied in the agriculture. So, for example, just using it for crop monitoring, it's something similar that Iman said. So, just to depend on satellite images and the drones to just capture the images for the crops and analyze its texture, colors, growth patterns, and all these things, and they develop historical patterns based on that. And after that, you can generate analytics data that can be benefits for the farmers themselves. The other one, and it is already implemented with robots or agricultural machinery to just make auto detection to the wheat and killing these weeds with laser beam or electricity to reduce depending on chemical to kill this wheat. So just replacing the chemicals by a laser beam, and they make auto detection to the weed based on computer vision, and it can be done with a separate robots or attachment to the machinery like this one in the image. Other one related to yield estimations is to just also have cameras based on drones or installed to plan logistics and manage supply chain for the yields itself before the harvesting and after the harvesting too. And in this type, we can think about best detection. Also, is how we can use the computer vision to make early detection to the pests, and also it's also can be used in drones, or we can, if we have cameras installed as stations in the field, and they make it capture images for the field crops and the auto detection for the insects or the insects results. The same also for harvesting automation. If you can of using machinery or robots for harvesting, so vision guided robots can be done through this. And the last one, and the most common in agriculture, is the fruits and the vegetables quality sorting. So we can sort fresh food based on size, size and the colors, and also internal and external defects based on a big sorting machine and on high speed. So we use it to sort, for example, orange, lemon, potatoes, and all other fresh vegetables and fruits. The last one is into agriculture, but from the livestock monitoring. If you have farms of cows or birds or something like that, so we can just throw this cameras and the software beside it. You can just check the patterns behind it and monitor the illness, stress, and abnormal behavior real time, and generate also a dashboard of data analytics of based on these videos. Then the last one, I think it is related to the agriculture about waste sorting and how we can sort the waste based on plastic type, for example, or organic waste, but also to make some automatic sorting based on that. And about the impact of using all of that, so we have economic impact related to increase the productivity and the cost reduction, and also building a market competitiveness. And the social impact from here is also about job transformation, that we transform the jobs to be more smarter than before, that support sustainability and rural development. And I will just ending with something or tips and tricks to plan for your AI project. And I think it is important here, as we have a lot of maybe farmers or customers or agricultural companies that need to build something, but they don't know how. So this canvas is helping them to see how they can build an AI project in general. So they can just start with the data itself, which data that they have, and also the problem classes. So the problem is that they have and wanted to solve, and the data related to the problem that want to collection, and the methods of data collection, and also the solutions. And after that, they can put the value of proposition from these solutions that wanted to be done, and data sources, and the integration and user interaction. All this canvas that will solve the problem of how you can approach and building AI computer vision solution or project in a seamless way. As based on our experience, a lot of hassles happen when you start trying to solve your problem. If you can make it based on your company, inside your company, or outsourcing it, also a lot of hassles happening here. So this approach can solve this problem and fill the gap by defining the problem and solution, and also defining the data needed and its resources. So just that's it. And you can check tuba.ai and try it by yourself for free, and send me if you need any questions. Thank you.
Thank you very much. Definitely, we'll come back to you with some specific questions. We just want to take all presentations first, and then we have an overview of what we intend to discuss today. And then right now, I call on the next speaker, Angie, please. Over to you, Angie. Thank you.
Can you hear me and see me?
Yes, please. If you would like to share your screen, you can go ahead, please.
Angie, we hear you, but we see a black screen.
Okay. Well, I opened two devices for this reason. Okay, allow me to share screen now. Okay. So today we're talking about a big data futures platform that we have developed called the Egypt Horizon Scanner. So this Horizon Scanner platform is an automated horizon scanning tool that incorporates custom features tailored to strengthen the anticipatory and adaptive management of users, to empower their decision-making approach to be based on evidence and data. So the idea in brief is we had a needs assessment workshop with people in the development ecosystem, different people like development organizations, market players, policymakers, and we wanted to understand more about the challenges they are having when it comes to data. We found that those three key highlights came out as decision-making challenges. The first was the need for having a new future-proof approach that improves their agility and quick response. And we mean by that, like, for example, if we're talking about people in agriculture, a lot of changes are happening, like climate change, like new technologies coming up, new initiatives, new policies, new financing tools, and so on. So how can we be agile and like change what needs to be changed and be aware of what's happening on an ongoing basis? How we can hack the different challenges and changes happening using a portfolio approach, like to hack the things using a systems thinking approach and not just from one angle. So these were the key challenges that were the direction or the reason or the guidance that we developed our big data futures platform for. So the platform is composed of those four features: response now, service
sorry
offer.
for cutting, but your presentation isn't moving if you are moving it. It's freezing.
Okay.
Yes, now it's moving. Yeah.
Okay. Thank you. So our platform, we call it for abbreviation EHS, is composed of four features: response now, service offer, digital avatar, and user experience. And response now has three further sub-features: emerging issue of the month, intervention mapping, and programmatic simulation. So response now is the feature that allows you to know on an ongoing basis, on a monthly basis, the emerging issues of the month, like whether we're talking about economic or social or technological or political signals of change that are relevant to your field. And how can they, like, which of these signals significant, which not, are they positive, are they negative, are they neutral? And if you want to design a new project, what would be the recommended intervention areas from the programmatic simulation results? And also, if you want to see like the ongoing development projects that are relevant to agriculture, where they are in Egypt, how they are, which government areas have those projects, so that if you want to design something new and you want to make sure that it is in an area where there is gap, so that it can be impactful. So we have here the intervention mapping that gives you this. We also have the service offer, which is if you're going to events or meetings with high-level people with the objective of making like deals or partnerships, and you want to link that, or you want to create the service offer that you want to offer to those guys, and link this to the ongoing emerging signals of change as well as the relevant data indicators. So this is the service offer. And we have the digital avatar, which is a one-stop shop for all existing data indicators that are relevant to your market area, which is today, since we're talking about agriculture, so to agriculture. And eventually, we have the user experience feature. This is the feature that allows you to make a data request for a topic that has no data at all. There's nothing there, and you want the platform team to collect the needed data for you, to collect the needed signals for you, and recommend the potential intervention areas that you can design your thing accordingly. So to build this platform, we had this protocol or these steps. So we first started things by developing the methodology, which is what would be our data sets that we will be using, what would be our data sources that we will be using. And we had a team composed of data scientist, software developer, mathematician, economists. So the methodology was like co-developed between the data scientist and the economist. Then we transformed that into the logic, and we built the mathematical model that the platform used to make the needed scanning that we talked about. Then develop that into the website or the software development. And then we had the testing and verification using user acceptance workshops to make sure that the platform is user-friendly. Where AI is in all of this. So AI constitutes 11% of the framework that this platform is built on. It's exclusively in the Response Now feature. So it's the role of AI lies in two things, or two sub-features, in the emerging issue of the month and in the programmatic simulation. So the emerging issue of the month, it lies in the sentiment analysis of the signals of change or the emerging issues. So the emerging issues, let's say, new technologies or new policy initiatives that are important on the future of agriculture. So AI classifies those emerging issues into positive, negative, neutral, and we also have it in the programmatic simulation feature, where the feature employs generative AI to extract the relevant information from various sources, and allows it to give the needed recommendation to guide the users on how they can invest their resources for maximum impact and efficiency. We also have conducted a lot of measures to mitigate hallucination, both during the testing and the validation phases. And we have used AI also to develop several tools like donors prompts, issues glossary, and qualitative data extract prompt. Those tools we used in collecting the data to guide in the information that the features of the platform provide to its users. I'll be talking more in depth about those two sub-features, which are the emerging issue and the programmatic simulation, since our topic today is focused on the role of AI. And then I will share with you the platform itself and take a small case study on agriculture so that you can visualize it better. So as I was just saying, the emerging issue of the month, it gives us those three things: top issue of the month, emerging issue, the top 5 issues, emerging issue, and the global regional emerging issues of the month. So all of these three, they change on a monthly basis. So we have emerging issue of the month. Currently speaking, the platform is localized on the Egyptian case, but it has the potential to customize it into very different countries. So we have those two levels. We have the emerging issues of the month over the local level or over the Egyptian context. We have it over the regional level or over the Arab region level. And also we have the top 5 issues from both. How we develop this? So we first the platform makes this horizon scanning on the very different data sources. So it takes from everything. It takes from governmental portals. It takes from think tanks, newsletters, everything, research agencies. And we, in order to make sure that it suits the context, we scanned the national documents, the country program document for development organizations. We had run validation and needs assessment, stakeholders workshops with the diversified stakeholders in the ecosystem. And we developed like historical margin error for the national indicators, so that to see when the indicator is considered to be an emerging issue. For example, if inflation rate usually is from this to this, and then it comes to a number that it has not reached before, then this is an emerging issue that we need to consider in planning for agriculture. We also bear in mind how does it emerge or develop those emerging issues. So it takes from all of these sources and all of these rationale, and then it gives us the quantification and impact assessment. So the quantification is calculated based on 2 things. The first thing is the frequency, on how much this signal category was talked about in the different sources, and also how much those sources are credible. So we had also weights survey on the different types of sources, and we incorporated the perceived credibility of these sources in the mathematical model that the platform is built on. And then accordingly, we gives the quantification of those emerging issues that guides us whether this signal or this issue is moderate, is weak, is strong, to give guidance on potential impact of whether this is an opportunity or a threat and why. Then we also have the programmatic simulation. So the programmatic simulation, it gives us a recommendation on potential new projects that I want to design, bearing in mind that the performance of previous relevant projects, their previous contribution to SDGs, the risk factors, the vulnerability maps, and previous budget performance. All of this it takes, and it gives us the recommended intervention maps for designing new projects, where it should be, what is the recommended budget, and what is the recommended budget breakdown.
Thank you so much, Angie.
One last 5.
Yes, probably you can just round up, please. Yes, thank you.
Yeah, I just give you a small, like, to show the platform together. No, not this one. Yeah, so this is how it looks like. This is the emerging issue. As you can see, the top five emerging issues. We have here the different emerging issues. If we highlight, you can see the percentage is the significance level, the type, whether this issue is environmental, economic, or social. We have it also over the regional level, and we have the data analytics for it. So for example, if you want to see something, wheat shortage and high prices, for example, those are the relevant signals on them. whether they are positive, negative, and neutral. And we also have the source if you want to like read more about this thing. So we can see the different signals that are relevant. You can see a lot of things relevant to agriculture, wheat shortage, sugar crisis, wheat supply, food security, and global trade challenges, you know, a lot of things. Then we also have also the programmatic simulation thing that I was just explaining. So if I want to design a new project, so here we have agriculture. And let's say I want to develop a smart agricultural project that empowers small farmers, let's say. And then we have simulation. It takes some time because of AI. Yeah, so it gives me like that. It gives the recommended intervention areas, like where this could be. So here it recommends Delta. It's in the north of Egypt. Recommends to have like partnerships with cooperatives, agricultural extension services, financial institutions. It recommends like where exactly the intervention areas should look like. And as you can see, it also recommends recommended budget with its needed breakdown. And the more info we give, also it will give more insights.
Thank you so much. I think we'll come back to you with some very specific questions in respect of impact, trends, and sustainability support. So thank you for that very interesting presentation. Right now, I call on Katrina. Over to you, please, Katrina. Thank you.
Okay, just a second. I'll share my screen. Do you see my screen?
Yes, it's coming up. Yes, please.
Do you see the presentation?
Yes, please. Maybe you can just take it slide by slide. Thank you.
Yeah.
Yeah, it's clear, very clear. Thank you.
Sorry. Oh, sorry. I'm sorry. Do you hear me?
Yes, we can hear you. Please.
I'm sorry. As I'm in a hotel, so I decided to use my smartphone just to be connected, and I had a call from my daughter. I'm sorry.
Okay.
Yeah, that's why. Well, kids
can you share your
call
screen
us
now? We can see your screen.
Just don't. Yeah, just a second. Do you see my screen?
Yes, go ahead, please. Yes.
Yeah, I will be quite brief because actually the main idea of our presentation is just to show some examples and just to give a better understanding of what we do exactly in the field of artificial intelligence and machine learning for precise agriculture. So here you can see some of our customers, because we have been working for many years in this field. And actually, let me summarize a bit all tasks that it's possible right now to do with machine learning somehow, let's say. Anyway, we can detect human being or animals, or we can detect any defect, or even small defect on for example, on a leaf of a plant, or on a platform under the sea. So there are different ways via machine learning to arrive to exact result of detection. The biggest problem is actually data set, because data set, it's fine when you have 1,000 pictures, but sometimes it's not it's not enough at all to achieve good results. So that's why we talk right now, and I'm quite sure you heard about it. We talk about explainable AI. So what we do is explainable AI. When data set doesn't give you the exact result, the engineers or AI engineers should understand in a very precise way why it's like that, and what kind of data set still missed to arrive to the exact result. So as we work with, let's say, precise agriculture, so precise, it means we cannot have a big error. So we have to achieve really good results to implement them after our solutions for the exact machineries, for tractors, or for some kind of agricultural drones, or some sensors. So in my few slides, you will see only real examples of real projects that we have already done. So here you can see actually plant detection and leaf segmentation. So all neural networks you can see from the pictures, they are already implemented and they are real, with some real results. So here you can see sensors on the tractors. So we use a lot of different sensors to understand not only GPS position, but also precise location of the vehicle, because for our autonomous vehicles without a pilot, it's very important to track exactly not only the work that has been done, that should be done, but also the work that has been done, and also the conditions where the tractor or the car agriculture vehicle works. So here is an example of our sensors that work between grapes. And the fact is that rows of grapes, they have quite raw paths to pass. And so the peculiarity of this task was just to detect in a very good way driving between these grape plants, detect actually different kind of or defects, or let's say disease or whatever we need to detect something. So there are different neural networks that were trained to give good results, and so here we are with some of them. Well, maybe for wood it's not very important because it's not a case. And this is another case which is very important. We detect with our solution different animals. So here we talk about the preservation of tigers, and each tiger has a particular design of his fur or its fur. And well, we can detect right now more than 1,000 of animals with different, let's say, peculiarities of fur. So actually, we work in such a way even with diamonds, for example, even with metal, with any detection of, so it's called defectoscopy. But the main problem, as I told you at the beginning, is a data set and understanding what exactly should be done with this data set. Because of course, more or less, any student, for example, from Politecnico in Italy can complete the simple neural network. So it's actually a usual task for a student, but to track and to understand what exactly can be done and how to improve this data set to get the exact result, that's the real case that should be done by experienced engineers. So thank you. I hope I was quite in time. And if you have any questions, then I'm open to answer.
Thank you so much, Katrina. That was a quite very interesting presentation and direct on point. Definitely we'll come back to you, and we have some very interesting questions as well, very specific questions. And now I take the presentation from Simeon Smith. Over to you, please, Simeon.
Thank you, Ken. I will just try to share my presentation and just project it. So welcome everybody. My name is Simone Smith-Godfrey. As I've indicated to you earlier when I introduced myself, is that I've joined recently Blue Economy Chamber of Commerce. I am a Blue Economy scholar of profession, and the following presentation is aimed at one, linking aquaculture to the agricultural agenda of the land, because that is what aquaculture is. It is the growing of marine living organisms on land. So it belongs under this portfolio, number one. And number two, its market has exploded. It became 4 times the market than it was, due to the impact of the 4th industrial revolution technologies. And in today's case, I will be looking specifically what AI can do for aquaculture projects. But now I would like to revert back to the fact that I belong to a Blue Economy Chamber of Commerce. And these are the kinds of activities that we are busying ourselves with. Thus far, I've received quite a wealth of information of the 3 previous speakers. And I would like to issue an invitation to all 3 of them to take parts of our conversations offline in a different format. But back to the presentation of today. Let me give you a brief introduction into aquaculture. It is also known as aqua farming, in certain regions. The importance of it is the undeniable role that aquaculture plays in food security. The world has got 3 problems. That 3 problems is the carbon footprint, energy needs, and food security. And that's where you find an application of traditional aquaculture. I will indicate to you how technology has changed that and what role aquaculture has played in it and will be playing in it. The statistics of 2018 shows a production of 114 million tons. But in 2024, and keeping in mind we're in September in 2024, that production was already 223 million tons. So that is a doubling from 2018 to mid-2024. So yes, this is a rapidly growing market. It is a growth sector and is of great value to the African blue economy.
Hello,
The
Simeon, please. Is your screen, is your slide moving? Because
no, I'm still on the first slide. I haven't moved.
Okay.
Yes. So did it move now?
Not
Did
yet.
it move then?
Maybe you could show slide by slide.
But
It
I've
shows
moved to it.
a group of slides together, so you need to choose the first one.
In other words, you are still on the first slide.
No, we are seeing group of slides.
Okay.
Okay, now it's showing one each. Okay.
Okay. Does it show the?
Yes.
Does it show the presentation view?
Yes, just one. Yeah.
So how do we link aquaculture to agriculture? First of all, the integration between the two creates synergies between farm enterprises, because waste from fish farming can be used as fertilizers as crops. In other words, you are participating in circular economies. For food security purposes, when you run a system like this, it enhances your chances for it. And an example of it is in China, where rice fish farming has been used for more than 1,000 years. So it's a pretty solid method to use. So when you look at aquaculture as farming and the blue economy, now you're bringing in a very different element into Africa's coastal communities. This is farm practices that are combined with a very pronounced focus on sustainability management that is a characteristic of the blue economy. And in this case, it would function as a mechanism to reduce the pressure on wild fish stocks and support marine ecosystems in the same process. So the example for it is integrated multi-tropic aquaculture systems, which combines different species to create a balanced ecosystem. The market overview for it is currently sitting on 405 billion US dollars for 2033. That is in 9 years from now. So if you're sitting on a production right now of 222 million tons, and that is the value that you're working towards, it makes for some good maths. There are 4 markets in this industry. Historically, there used to be only one: consumption. Export for fish and sea plants out of Africa of about at least 80% of everything that we get out of our EEZs, and then the rest for domestic. That exploded with the application of fourth IR technology, and marine biotechnology applications entered into the forefront. Application of that is cosmetology, where we're using marine products in beauty and skincare, pharmaceuticals, which has got fish products and sea plant products that has got health benefits and therapeutic applications. The stats for it is that the market was 204 billion in 2020. If we talk,
Simon, please, your slide is not moving.
my slide is not moving.
Yeah. Okay. It's on slide 5 now. Continue, please.
Okay. So if you're working from a base of $204 billion in 2020, and you are projecting to be at 445 billion by 2023, which is a 9-year trajectory, that's some solid steps that you've got to exercise in the market. Let's go look how it can actually be done. What is happening with consumption of fish? is that we've moved from 9 kg on a plate of fish to 20.3 kg in 2016, which is about 8 years ago. So those numbers have changed, especially because they're coming from before COVID. But over the past
next slide, please. Next slide.
Over the past 3 years, this has changed dramatically because of the deployment of blue financial instruments into Africa's coastal economies, which created a pool where there are available monies, but only for very solid projects. And much of those projects speaks directly to technology enablement, where AI features prominently. Did the slide move, or do I need to?
Not yet.
I'll navigate back.
Okay, it's on 7 now.
This also expanded into consumption of sea plants, seaweed and algae, specifically because they are rich in vitamins, minerals, and antioxidants. Some of us who've got teenagers would be perfectly aware of this glass skin trend of Korea. Seaweed plays a very important role in the achievement of that cosmetology miracle, some might want to call it. Let's look at for marine biotechnology under fish. We used quite a bit of genetic engineering to enable selective breeding. But this is for the developed world. For Africa, where we stand with marine biotechnology with regards to our fish, we first need to conduct an eDNA cataloging project where we go around the coast of Africa and we catalog our species in accordance with genetic material so that we can assign markers to it, so that we can highlight them very specifically into research pipelines that focus on specific characteristics that comes out of that species that has applications in especially marine biotechnology, but also in consumption where it comes to broadening the variants of species that does come onto plates. I will navigate back and project the next one, which is marine biotechnology for sea plants. You have right now the production of biofuel and biofertilizers. However, the products is not limited to that. The products includes drugs. You can generate stored packaged eco-friendly biodegradable batteries from some of these things, food enzymes, compounds, and then of course it serves as DNA blueprints for when you are gathering your genetic material and characteristics of your species deployed on your EEZ. I will move over into cosmetology of fish. Some of us are familiar with the products of Garnier and Neutrogena. They are very common beauty products in our markets. When you look at their anti-aging creams and their serums, the collagen that they are using there is coming from fish scales. So if you an aqua farmer or an aquaculturist, you're no longer producing just for consumption for the foreigners. You have many other markets now to choose from. I'll move over to cosmetology of sea plants. Also to quite familiar products. And just to note that beauty brands have bought into this already. La Mer and the Body Shop, they've got their own dedicated cosmetology skin range that's running off inputs from the oceans. Just as a note of interest, Himalaya, I'm a user of that product. So I live so close in that marine biotechnology area that I'm deploying it in my regular life every day.
So we'll take your conclusion statement now because time it's your 10 minutes over. Thank you.
I will then jump straight down to the AI application and feasibility for Africa. One, we need it for monitoring purposes for water quality and fish health. So the area of what Mahmoud is presented comes into play there. And I saw Katerina also highlighted for disease detection. And then I noticed from what AMG is highlighting that feasibility of leveraging the tech ecosystem with digital infrastructure is already playing here. So I thank you for the opportunity. I do see the markers of growth in the industry. It's a pleasure to have introduced this field to you, where it comes to the future of aquaculture in Africa. I would like to point out that where we are now in the African agenda, it is about everybody pooling resources and skills together so that we can work for fostering a greater good whilst we're making a life out of it. And as such, I would like to invite you to connect with me off this platform as well. But thank you for your time. I hope you've got some questions.
All right, thank you. Thank you so much, Simeon Smith. Geoffrey, we really appreciate your presentation. You're giving us a different, another perspective from the marine world. So definitely we have some questions for you. And now I come back to Imam. Imam Ibiri, please, your presentation. Over to you, please, Imam. Hello, Imam Ibiri. Robocare.
Hello, sorry.
Yes, over to you, please.
Can I talk later? At the
Yes,
last?
please. Yeah, you would like to
switch
speak.
with the final one.
Yes, yes. Okay, you can present your slides if you want. Over to you, please. Thank you.
Thank you.
Hello, Imam. Are you presenting?
No, she wants to be the last one. Yeah.
Okay. Andriano, please, could you go ahead, please,
Yeah.
Andriano? Thank you.
Yeah. Yeah. 1 second that I share the screen and I switch on the camera. Yeah. Okay, should be able to see the screen now in a few seconds, the presentation. Yeah. Are you okay with the presentation? Are you able to see?
Yes, please, go ahead. Thank you.
Thank you. So first of all, thanks for this opportunity. I will try to present you some general aspects that we have in high, especially in agriculture, where we are working as a university. We are in the center of Italy, and we are in a beautiful place where we have a lot of fields, mainly wheat and cereals. So first of all. So my university is University Polytechnic. So this means that we are engineers, we are scientists and agronomists and so on. So that's really important because when we have projects, and we will talk about projects in a few minutes, we have a lot of cooperation among engineers, agronomists, and so on. So this is really important from my point of view. First of all, I will try to just to summarize a few main aspects that we have in Italy, but is common problems that we have also in Europe, but of course also in Africa. As we know, now we have a lot of opportunities for LLM, so large language models, that could be used for several aspects. So to provide, AI doctor, AI agronomists for farmers that they need technical support. This is a common problem, especially in rural areas where we have no opportunities to visit often. Technicians could not be there because it's really expensive. It's not so convenient. So most of the time it's necessary to have tools that are able to say, okay, let's take the data, for example, images and so on, and let's try to analyze and provide maybe some feedback regarding potential problems and potential solution. I will show you an example later. One other problem that we have now is the lack of open data set. This is a common problem that we have. From the previous speaker, we know that this is a common problem. So this is still an open issue, and we'll try to give you an example of what we are doing in our university to fix this aspect. And also in our region, we have an evergreen problem, that is the digitalization of the processes on the farms, still having issues to introduce not AI, but to introduce the digitalization. So farmers are usually have analogic registry to track and trace the operations, so it's not easy. So this is still an open problem. It's a cultural problem, of course. And we have to think about that the new generation of ag machines that are intelligent, because we are planning to integrate a lot of AI inside. So as we have in industry, we will have, of course, in agriculture. The problem is that is now for large farmers, it's not for small farmers, because the costs are not feasible. And there are other opportunities that we have to discuss. This democratization, not only developing countries, because small farmers, as I said, is actually they represent the major, especially in Europe, of the market. So this is a really important point. And of course, and we have done a lot of projects on that to manage in a proper way the resources that are water. Now we have facing with a scarcity in a lot of region in Europe, and of course to keep soil fertile as much as possible. So just to give you another point that we have also in Europe, but also around the world, this is a really interesting aspect. So today we are talking about opportunities of AI and so on in ag, that we have to discuss that. A recent report states that we have a lot of opportunities for AI specialists, robotics engineers, and it's really surprising that we have agricultural equipment operators that are in the 9th place. Why? Because we know that the future is along this way. So AI plus intelligent machines on the field. But we have to face a lot of problems from the point of view of budget and feasibility for the investments. So one really important point, why I start from LLM, we know very well, so I can skip, of course, these slides. What we know maybe well is the trend. The trend is this, so you can see that the number of the models, the size of the models, the performance of the models, and the cost of the models is continuously growing up. So why this is interesting? Because for agriculture, multimodal LLMs could solve a lot of problems. We are working on fine-tuning of these models to provide solutions and find maybe precise replies to farmers on particular, of course, areas. We cannot retrain it from the scratch, but what we can do is to fine-tune, and this is something that is feasible, because when we fine-tune a model, then this is a common approach that we can do in an easy way by embedding the knowledge of the agronomist, for example, inside LLM. What is really important to consider is that we have facing a lot of problems from the point of view of environmental sustainability. So just to mention that one important aspect that also the other speakers they just mentioned it, in a lot of the cases in agriculture, we have to work in rural areas where we have no internet connection, where we have edge devices. So one really important aspect is to try to optimize as much as possible the models from the point of view of complexity to run on low-cost hardware. And this is another aspect of our research that we are performing in your university in cooperation with companies to optimize the model, reduce the size of the model, and make the inference on edge devices. And this is really complex because we have to ensure the performance. So also take into account that now the cost to train a large model is not feasible for research center and so on. You need to invest millions of euro, millions of dollars to train a large language model. So we have to work on the fine-tuning, of course, and the optimization of that. Just to mention that we in Europe, as around the world, we have a lot of HPC infrastructure for that. So one of these is in our country, that is Leonardo system, really high performance system, but I will skip on that because it's not maybe of interest. But this is a really important aspect. For countries, is necessary to have, of course, models that are not managed by tech companies. Maybe at the national level, it should be nice to have models managed by the university, by research centers, because if we depend by tech companies, this is not good solution for also for developing countries. One important aspect, just to mention you, is exactly what I'm saying. So we have seen a lot of AI-based solution for the farmers, also from the other speakers. But as I just mentioned, we have not to fall in a total dependency on the leading tech company. This is why we need to have the infrastructure for a new generation of AI models that should be explainable, of course, but should be also trainable. And the trainable, it means that we need infrastructure to train models, also at the national scale, to have open models. This is another point. So what we are doing in some cases, just to give you an example, we are contributing in several European projects to collect mainly images, because we are mostly expert in image processing. And just to give you an example, we have the interaction with citizens that can provide images, annotate images by using their mobile phones. This is an example of a European project. The name is Increase, just to have citizens that are involved in the growing of beans. So this is really interesting because we send to the citizens the beans, and they grow on their houses the beans, and they track and trace the monitor of the growing by using a citizen app. What is interesting is that you can see an example of a LLM that is able to reply to also the complex question, also integrating a really huge data set that we have now, for example, the iNaturalist and the GFIF database that allows you to have a lot of open data that you can also integrate in your model. And this is something that we are doing now. Just to give you another example, is that this is the future, and we are working a lot with farmers to work on that. Just to say, okay, let's take an image and let's try to identify which is the disease, with the source of the problem and the mitigation of the problem. You see also the suggestion of the products. This is really important because in rural areas, as I told you, this is a way to have an interaction with a farmer and with an expert, in this case AI, but of course the AI needs to be supported by the agronomists and experts to have continuously updating the model, because we know we have new products, we have new diseases, so it's really important to keep the model trained and updated as much as possible. So we have several challenges. I will skip because, of course, I want to focus just on other points, but we need to work a lot with the farmers and with the specialists and with the experts, because the domain-specific knowledge is really important. We can map the most widely diseases, but it's not enough, because we need also to take care about the specific problems that we have in specific areas. The data availability and diversity, this is another problem. We know that in Europe is different from Asia, Africa, and so on. So the model should take into account several data sets to take as much as possible the diversity that we have over the countries. Other problem is that, as I told you, a lot of challenges from the point of view of processing. Real time is really challenging, as also the integration of different kind of languages, because we have to interact in natural language. In most of the case, we cannot speak maybe, for example, English or specific language. So we need to be sure that the LLM should be also available to support the farmers and the agronomists also in different kind of languages. So This is another problem, just 2 minutes, and we'll go through the rest of the presentation. Dataset is still an evergreen problem because we usually train the models. If we have a bad data in, we expect to have bad results in out, because this is something that we commonly expect. Just to give you an idea, when we talk about the collection of the data, we have usually just a small portion of the data structured, and this is a problem because we spend too much time to provide the processing of the data. So we have to spend the data to analyze, not to pre-process the data. So one critical aspect is the data annotation that is really costly. Actually, we involve several experts in the data annotation. That is actually one of the main problems, because you have to spend a lot of money, a lot of time to have high quality data annotation. Otherwise, the risk is that you have rubbish and then the results are not enough. Of course, what is really important is to try to integrate as much as possible, different, areas. You see some example here of images that we have in our facilities where we try to collect, for example, the width over the farms, just to train models to be able to detect in early time the presence of the width over the field. But we know that widths are different from Europe to Africa and so on. So it's really important to have the possibility to get a lot of data. That is the main problem. And another problem that we have, often speaking with the farmers, is the data privacy and ownership, because this is a really critical phase. We can have a dataset, we want to have dataset, but we have to respect rules. This is another point, and this is really critical, especially in Europe, where we have critical rules for that. One important aspect, just 1 minute more, human power at AI. As I told you, one interesting solution that we have now is to use the citizens, to use the expert to label the data. One experiment that I want to mention you is our project that we have is a citizen science app that we developed in the context of large European projects. As you can see, we have seeds. We give the seeds to the citizens. They monitor the seeds over the time, so from the seeding to the growing to the harvesting of the beans. And what is really interesting is that we take photo images directly annotated by the citizens. This is interesting because we can involve people, experts in the domain, to label the data and to have common open data set. Because if you want to have open models in agriculture, we need to rely on open data set, of course, and this is still a challenging problem. Just to mention a few interesting projects, and if you are curious, we can talk later, of course. 1 more minute, no more. Is interesting to this project, the first one, because it's Digital Water City. We take the water from the wastewater treatment plant. So usually, the water that is dark water, so from the citizens and from the cities, and we give new life to the water for water use. So we can use that kind of dark water, dirty water, to irrigate. So we have worked for that, preventing, of course, the health of the people. Another project that is really interesting is to use AI for food loss reduction. So we are working a lot with several farmers and several companies to have solutions for reducing the food loss in the production stage and increase just mentioned. 1 slide more. The partners that are really important. We have at our university, as in other university, and several experimental areas where we can do tests and trials. We are placed in that side of Italy, so in the east side, and we can test several kind of crops with different kind of soil management, water management, nutrient management, pest management, and so on. That is really important for that. And we say also thanks to special partners that they cooperate with us. One of these is Filtronics, is a company in Italy that is working a lot in smart agriculture, especially to just to show you, to perform experimental test field, really complex with several trials and perform ground sampling, field data analysis by using several sensors. I have no time to go into details. Aerial data previously was mentioned at the use of remotely sensed data. Also, in this case, we have a lot of devices for that. As the lab analysis to establish the correlation with the nutrient content inside the leaves and so on. So a lot of stuff that could be done and a lot of data to acquire, of course. And last strategical partner that we have is the TopCon that is supported us over the time to have the trials that I just mentioned to you. And they have a really strong coverage around the world. Is one of the leading company in this area. And in particular, we cooperate with them for the platform that they have, that is the TAP, where it's possible for the farmer. You see again, the name is Mentor AI. Why Mentor? Because we talked at the beginning, we need doctor, and behind the doctor, the agronomist, maybe we can have an AI agent that is able to reply to common questions. But agronomists will be necessary, as expert will be necessary. So we are not replacing. We are giving the opportunity to have a higher chance to interact farmers with, of course, with experts. That could be real experts or could be virtual assistant experts. So thanks again.
Thank you so much. Adriano, that was a very interesting presentation as well. And definitely, I'm sure we have questions for you.
Yeah.
But first, we'll take the next presentation. Ebenezer, please, over to you, Ebenezer. Thank you.
All right, thank you. Let me share my screen. Is it showing now?
Yes, please. Could you? Okay, please go ahead. Go ahead. Thank you.
Oh, all right. Okay. So I just want to briefly talk about what we do at the center, that is Earth Observation Research and Innovation Center. This center is the research arm of the University of Energy and Natural Resources, and we are responsible for the acquisition of near to real-time satellite-based data. We are also into airborne and in-situ data. We also offer automatic weather monitoring and operations of unmanned area systems. We also are also working in virtual regional fire monitoring and modeling. We also organize training programs for corporate institutions and individuals. In fact, we also deal with our name. You can see that we have Earth observation there. So we are also into Earth observation and geographic information systems. We are all doing this to actually help the government take decisions, that is data-driven decisions, in areas of water, disaster health, energy, climate change, agriculture, ecosystem, and biodiversity. And we also have a mandate to add value to our data sets, that is for research and education purposes. And we are also trying to make space science skills very affordable for everybody to afford and to spread it widely. Okay, so these are some of the things we do. We have about 10 years experience in Earth observation services. We have some ground stations, which we use in the center to track some of these satellites you can see here. Our ground stations are able to track the NASA Terra, NASA Aqua, NOAA 18, and the rest of the satellites you can see here. We also offer ground station hosting services. So we are hosting several ground stations with other international bodies, that is space agencies. And I'll show you shortly some of the stations. So in all, we have 4 ground stations, and 1 is under construction currently. And in the 4, we have 2 full motion antennas that support telemetry tracking and control or command. We also have 1 fixed antenna, and we have the GNSS referencing station, that is the Global Navigation Satellite System. Like I was talking about our services, we have we do hosting services. We are also into ground station installation. That is when it comes to the consultancy procurement, if you want to import everything. And we also give 24/7 project management and maintenance of these stations. We are also into the telemetry tracking and command services and other services, as you can see. So these are some of the ground stations. This is the first ground station that we had in 2013, but this was funded by the Ghana Skill Development Fund. And the center was first named by this ground station as the Jonetka Center. And this one is the Umicast Jonetka Reception Station. This is the second one that was installed in 2015. This one is the Earth Observation Satellite Direct Broadcast. And this one is a 2.4 meter high, high precision antenna. And this one tries to track satellites in the low Earth orbit and the medium Earth orbit. And as you can see, we track satellites such as the Terra, Akanoa, Mesotop, and Fungi. Okay, in 2016 also, we had this ground station from the Cosmic 2 project, that is the Constellation Observing System for Meteorology, Ionosphere, and Climate. And this ground station is one of the 9 ground stations that we have across the world. And this one is jointly operated by the University of Energy and Natural Resources and also Atlas Space Operations. So that is it for now. We also have the Global Navigation Satellite System. This one was to support the Cosmic 2 program. And this one is also jointly managed by the university as well as the University Corporation of Atmospheric Research. Also, we also support satellite launching. In 2019, in fact, the center supported SpaceX in launching one of their satellites into space. Okay, and currently, we started this project that is the Carbon Black Tower Monitoring Project in 2018. We completed this project last year and it's now in operation. The whole idea about this project is to try to monitor and understand and quantify carbon or CO2 exchanges between the atmosphere and tropical forests. In fact, Ghana is not having this facility. And even if we want to scale it, West Africa, we don't have this facility. And as the world is going into global or going into carbon finance, this is one of the important infrastructures that we need to quantify our total carbon or know our carbon balance. And this one is in the center. Okay, the center is also having an environmental fire laboratory. Here we try to, or we were tasked by the government to actually predict wildfire incidences in rural farms. In fact, this was a predominant issue in northern Ghana, and we were given funds by the SDF to actually create models or algorithms that could predict fire, show their location and their direction and sometimes their distances, and try to give alerts to rural farmers on where the fire incident is happening. And we had a big challenge when we're trying to deploy this project, because we realized that the rural farmers were, one, not having phones, some of them. Others which were having phones were not smartphones. They were using these normal phones. And those who also had a smartphone, some couldn't even read what we sent them. So it was a challenge. And after the project, we decided to, one, we have to create a radio system for those who are not having phones so that we can send the information to them. And also those who couldn't read, we tried to send them voice notes so that they can listen. And these voice notes were translated from English to the various dialects that we had. We also created, or we provided training programs for these farmers and some stakeholders. And this project was jointly funded by the Ghana National Fire Service and NADMO, that is the National Disaster Management Organization. And they were all there and we trained them. Okay, we also have the High Performance Computing Lab. This is where we try to train individuals, corporate organizations, and students in high performance computing. Some of the things we do is computational fluid dynamics and artificial intelligence. And we try to also collaborate with other centers and industries to actually disseminate what we do. We also provide consultancy services in this area. Yeah, so one of the trainings we deployed in the Department of High Performance Computing was this joint workshop by NVIDIA DLI and the center. This one, we were trying to introduce participants to GPU accelerated programming, where they can leverage on their CUDA cores or GPUs to actually develop AI or deep learning applications. That is in areas of computer visions, autonomous vehicles, finance, game development, health, and robotics. Okay, we are also into training people in satellite communications, and this is an ongoing training workshop that we are organizing. And this one is funded by the Ghana Skill Development Fund. We are trying to introduce participants to satellite communications, into very small aperture terminal, and site selection for the installation, and a whole lot. We are also into Oman area systems for precision farming, where sometimes when we are consulted, we provide these services to farmers and to other organizations. We also try to train people in using these systems. We also have our automatic weather station, where we try to give weather information to the center and the university as a whole. Thank you so much. This is my short presentation.
Thank you. Thank you. That was very informative, and definitely we'll definitely have some areas, some questions in respect of training, capacity building. And now we take the last presentation from Imam Roboke. Imam, please, over to you. Thank you.
Hello. Thank you for the invitation. I will share my screen. Do you have my screen?
Yes, please go ahead, please.
Yeah, so I will be very brave. RoboCare is a spin-off from R&D Research Center. Is the co-founder as a professor in satellite image processing, and me, I have my PhD from USA. It's RoboCare is an American Tunisian company, and with us we have professor in agriculture. So our mission is what exactly is to transform the innovation, the research to farmers, to the field. This is our main mission, is to provide farmer recommendation on the best practices. This is based on satellite data, on drones, on sensors. Whatever is the source of data, is our main mission is to transform this big technology and this source of technology to farmers, so that the farmer can understand what to do, and to focus more on impact on farmer rather than other things. This is our main mission. So what we do exactly, we scan, the farmer have a subscription to our platform. We get the limit, the boundaries of his land. Then we scan his land. We have two offers for smallholder farmers. We charge him $1 per 1 hectare per 1 month. So our offers for smallholder farmers is $1 per 1 month per 1 hectare, so that he get, when he subscribe to our platform, he get recommendation what to do, what the problems he have, the irrigation plan, the irrigation calendars, and what he needs in his language. Then we run our AI algorithm on the data that we get. The data that we get for the small, we have two types, as I said. The smallholder farmers, we use only satellites. It's free satellite, Sentinel-2 satellites. We use this data in addition to the data that the farmer provides, so that we can support him in his daily and activities. And finally, you provide him a tool to optimize his practices. Today, we have customers. We have customers in Tunisia. We developed more in Morocco. Our plan to have more customers in North Africa, Algeria and Libya, and then we go to the other African countries. We support our farmers. We help him to improve their productivity by 30%. Yes, it's up to 30%, because when the farmer gets an alert, inform him at the specific GPS point who have a stress. At this moment, we just notify the stress, but our mission and our roadmap to identify the source of stress. If is it irrigation, if is it fertilization, or is it disease stress. And also we help him to improve his revenue up to 20%. This is by reducing the cost of water, the cost of fertilization, and the preventive pesticide and energy. Today we help our customers to decrease the use of pesticide and fertilization up to 20%, and especially water use up to 25%. I will log into the platform to show you what we provide exactly to the farmer. I will go. The farmer, he will get an account to our platform. He get an account to the platform. We start with 1 free month that he tests and decide if you want to buy or not. This is our strategy, so that we encourage. We have two objectives. The first one, that we encourage farmer to test before he buy, and the second objective, to get more data for the free demo. The free demo is to get the data, the field data, so that we use it in our AI models. So the farmer, he will get the dashboard where he present the total surface and the agronomic reports. Then he will click to project. In this project, he will have all the lands that he already have, because one farmer can have many lands at different places. So he will go to this land, what he will get exactly. For the smallholder farmers, this is an example of smallholder farmers who will get the indexes, also all the indexes, the vegetation, so that you will get a special map in the space. The irrigation, what is the zones with good irrigation and the bad irrigation. The green one, this is a good tree, and the less green color is less vegetation green, and the red, there is problems in the trees. The second one, I will switch to English. The second one is the nitrogen map. The fourth map is the plant health. This is based on the chlorophyll parameters, because when there is a decrease in the photosynthetic activity of the plant, it will be decrease in the chlorophyll. Consequently, we alert him that there is a problem according to the plant. We also count how many trees he have, the number of trees. We also give him KPIs indicator on which is the best one, which is the bad one. There is 50%, for example, good one, 20% at the average, and 10% is very bad trees. He want to more react with them. This is all in the part of the spatial map. For the temperature map, through this one, he go up to 2017. From the 2017 up to today, he will get the data from his land. As you saw, this is what we get there. This is the cycle, the physiological cycle of the plant. This is an olive plant. So this is the pattern of the plant. Then when we have this data, we use the data so that we present a forecast model, so that we can alert him when there is problems. The blue one is the rain, and And this specific farmer have a problem is due to the climate change. He get problem, so that we recommend him that have additional water sources. He can also compare 1 year to another. This is the first one. The second one, we provide him the farming practices according to the age of the plant, according to soil type, according to the weather, according to the images. We recommend him how much he should irrigate, how much he should open his valve, and which type of vitamins and fertilization he should use. And finally, when there is problems, we alert him. He will get in the same platform the weather data, 16-day forecast, and so that we when there is a problem according to the humidity, to the weather, we alert him. We tell him according to our AI model. We inform him that according to the specific weather condition and the specific land state, you can have disease at these dates. And finally, a precise irrigation plan. This is based on humidity sensors. This is for big farmers. This is based on humidity sensors. We have 3 levels: 20 centimeter, 40, and 60. We don't provide sensor. We have partners where we buy sensor from them. And if you know also good partners to buy, we buy sensor, pH sensor, humidity sensors. We buy sensor from different partners, and we install them and in the farm, so that we guarantee that the sensor is well functional and integrated to our platform to decrease the risk to our farmers, because we want to encourage him to use technology and decrease the risks. So that we inform him how much he should irrigate every day. This is according to irrigation plan. In addition, we inform him that we compile another good feature that is very used in the platform, that we tell him you are better or worse than your neighborhood, then another farmer with the same soil type, with the same agriculture and the same age. We have models that have the standards of the plants at this specific age. You should have this specific production. If you don't, why you don't? If is it you don't irrigate very well, you irrigate more than the needs of the plant, you have problems you don't use vitamins. So this is what we focus. Our what we make as unique, that we have in the same team an agronomist, we have doctors, we have agronomist engineers in our offices. This is our main point strength, is that we have the agronomists that understand more the need of the farmer and transform what we have, the EI team, the data science. They transform the technology to data that the farmer can understand, data that is not very expensive. $1 per 1 month per 1 hectare is very cheap in Tunisia, and it is affordable to farmers. We are not getting money from the smallholder farmers up to now, because this is financed by national units, by GIZ, by international corporations. We get funds from them, and we distribute the platform to the smallholder farmers. I don't know if it work or not in other African country, but I have just experience in Tunisia and Morocco. For our the smallholder farmers, for us, is a source of data, free data, because they support us, and ever we provide the farmer for free. For the smallholder farmer, they support us in our data collection. We have a team that calling the farmer every day to get data to the platform, because when we start, we have today 4 years old. When we start, we get the challenge, very problems. There is no data. And when we go to the farmer to get data, there is no historical data. 10% of the Tunisian farmer have historical data of what they did last years, because when we want to run our models, we need to have data. We will never talk about AI, we will never talk about data science if you don't have data. So that's why for the four passing years, our main strategy is to get the more and the more data, and we have just 1 year that we start selling the product. Today we scan 50,000 hectares. Through these 50,000 hectares, we have all the data from this area, and we aim to more capitalize this data and provide better and better recommendation to our farmers. Thank you.
Thank you for that very interesting presentation, and definitely we'll have some questions as well. And we have come to the point whereby we have to focus on the main issues, the main specific points, which we intend to discuss today. And looking at the time, I think we'll just take very few questions in respect to strategic impacts, assessment on socio-economic and sustainability roadmap for agriculture in Africa, the trends of innovation and future prospect, capacity building, job creation, research and development partnerships, especially with our international partners, the policy, regulatory reforms, and sustainability roadmap. So, dear speakers, I would like us to take each of these points. How do we position AI vision strategically in the agricultural space in Africa? We have listened to various presentations, and it's time we look at a strategic roadmap, strategic collaborations, and we would like us to take each of these points probably in a 2 or 3 minute statements. What do you think would really benefit African farmers to adopt AI vision? So in this order, I would probably like us to raise our hands. That would be a more preferable approach. If you want to have the first shot, please, over to you, speakers, and we start taking counts, and you just have like 3 or 5 minutes to speak on the main issues, on the main impacts you see that Africans should embrace AI vision in agriculture. So, Imam, you want to have the first shot? Yeah, please, over to you, please, Imam.
I will start giving my opinion according to the AI strategy of Africa, and set a real use case. In Tunisia, for example, we already, with the government and the private sector, we already have a strategic plan on how AI and technology can be used by farmers. In fact, we can simulate it to other countries, because I'm not very familiar with the farming in other African countries. But it's according to, it's financed by the World Bank. The World Bank come and bring money to Tunisia to support the farming, and I'm sure that there is in all other countries that there is, the money is existing. There is no problems with the money. There is many international organizations that support farmers. The challenge is to put the money in the right place. This is the most challenging point, and decrease the corruption, and the final farmer get the impact. The strategy is the short term and long term strategy. The short term strategy that the government or the international finance technical solutions so that the smallholder farmer can benefit from it, and have a team that encourage them to use it. Like, for example, if you want to get a loan from the bank, you need to have already installed a technical solution. This is an example of proposition. A second one, that if you want if you want to get a grant or sufficient grant from the government, you must have used a technical solution and prove that you are already using tools that optimize the water. And especially for the problems of water scarcity, there is a lot of farmers that irrigate more than the plants needs. So that there is a strategy so that we limit this one, that they are using a lot of water, and support the farmers that they don't find water sources. This for the short term. For the long term, we with the Minister of Agriculture, we are building a database for all farmers, how much they own, and so that we can use this database at source for research center in agriculture, and improve the recommendation and the technology adoption.
Thank you so much. Thank you so much. And in respect of, these are very valuable information which you have shared, especially the model of international donors supporting your solution to be deployed to small scale farmers, as a kind of a motivational incentives. So I think that is a very vital point, which is a take home for us as well, and definitely for others who could in the future also engage you to see how you could collaborate in other African countries. And Adriano, I just want to pick a point from you.
Yep.
What would you expect in respect of partnership, and which partners would you look out for in Africa? Or are you already engaged in Africa? And what are your experience so far?
So thanks for the question. First of all, our university started to cooperate a bit with some countries in Africa on different kind of projects, especially for teaching, not from the point of view of a classical way of university, but we take the professor in agronomy, for example, and then we visit the farmers, we visit the association of farmers, and we try to transfer our knowledge, for example, to your farmers, because we share the way as we practice the agriculture. But of course, when we're talking about the projects, is really interesting to try to engage new frontiers, especially AI. So when we are talking about cooperation and the potential partner and so on, first of all, I think that should be really interesting to try to work on projects where we can have common problems as the management of the water. So irrigation and soil fertility should be really interesting topic where AI could solve a lot of problems. So from the point of view of cooperation among Europe and Africa, and especially Italy and Africa, I know that there are several initiatives also promoted by the governments. It depends mostly on local countries, so it's not general, for Africa, but especially for countries. So if we can transfer, if we can be engaged to try to transfer our knowledge in AI and in agronomy for water management, soil management, and so on, where let me say it's really interesting, because we can of course evaluate initiative to collaborate together, of course. So companies or university or research centers are open from our point of view to discuss with us of potential opportunities, exchange students, for example, at the beginning, or try to visit and try to transfer, something to understand, the needs and then propose together maybe potential solutions. But we need to involve, the local governments or the embassy, because the cooperation is through this kind of dynamics, of course. Yeah.
Okay, thank you very for that very interesting feedback, and we have taken note of this, and I'm very sure you'll be having some very inquiries very soon.
Yeah,
thank
thanks.
you. Yeah, and Mahmoud, please, over to you. If you have questions, if you have clarification, please raise up your hand so that we will know where we are calling next. Thank you. Mahmoud, please.
Okay, based on your, I'll continue based on Adriano input. As actually I downloaded now the Increase mobile app, and it is very good to have the insights from different farmers or people around Europe about the crops and the beans. And I think we have opportunity to collaboration. So I will send you after the call, as I have another perspective about annotation and beans and the crops annotation that can be included in the same app, and we can support in this direction too, as annotation is a very boring and challenging task to improve or develop AI computer vision models. This is the first point. Second point is about the strategy and the regulation and something like that. I will talk from my perspective and my experiment, especially focusing on the quality in inspection and the fresh food sorting, and my experience here from actually is the same concept from Egypt, Morocco, and also the South European countries like Italy and also Spain, about sorting of orange, apples, potatoes, and all this fresh food sorting. And the problem is coming from the standard of sorting, and is that this. So if I will, the company will export to Europe, say it will follow the European standard, but it's have a lot of hassles if we are talking about the African ecosystem there. So I think is a need, or we need to put some standard for fruit and vegetables sorting to enforce the farmer and the exporting stations to follow this standard from the beginning. As we have a lot of hassles here for the sorting part. And all of this sorting machines is dependent on AI computer vision. So if we have a standard from the beginning, so it will save a lot of money and save also a lot of time. I mean, standard of defects, standard of chemical defects, standard of sizes, and also colors and all that stuff. The other thing is about chemical usage, and we'll continue on the same direction of that Iman mentioned. That I understand from here that she is depending on the fund from the government or global organizations to pay for the small farmers. I think it is the same problem here in Egypt, and I think it is repeated in other African countries, that if we're trying to push technology for the farmers, whatever they are, small or medium farmer, they will not pay for it. Even if it is cheap, also they will not pay for it. And I have my experiment for this, for computer vision technology, and also for IoT technology. But the only way to enforce it is to pay it by the government or the NGOs or something like that inside the country. And I think from my perspective that already each country have its payment system for farmers, like micro loans or fertilizers loan or something like that, or taxes. So it can be subscription or license based on the taxes or these micro loans. If this system can be applied over this financial ecosystem, so I think we can have a full standard data system per country that can serve the farmers, and it can be a one system including all. I think it is a big view for this, but the only way to be done by the governments and the leading organizations in each country. So this is my view about enforcement technology and how it can be applied there in each country.
Okay, thank you so much. Just a very good strategy. Ebenezer, please, over to you. Let's take your.
Yeah, thank you so much. I just want to comment on whether African farmers will uptake AI. I think in one of your questions, that was what you were asking. And I want us to quickly look at some of the previous things, that is Agric 3.0, the Green Revolution, and why some of the targets were not met. That is when we're trying to uptake the Green Resolution. So if you look at what we started, that is the Alliance for Green Revolution in Africa, the AGRA project. You know, if you read deeper into its implementation, in fact, it couldn't achieve some of its targets because of the following issues. And I think we need to really think about these issues so that we don't repeat them in trying to deploy AI in Africa. Yeah, so the first thing that was the issue was that there was a lack of consultation with farmers. And because of this, it was very, very difficult for the AGRA project to meet its target. And the second thing was the imposition of Western type technologies, which were not applicable, that is in reality in Africa. So I'm currently running a survey across Africa. I've been to 7 countries, and this is really happening. We are trying to introduce ratoon rice farming into different countries in Africa. And one thing we are realizing is that farmers are finding it very difficult to uptake new technologies because they look at the technology like we are trying to impose them on them. It is not from what they know already. So for me, what I'm learning so far from my field survey is that I think the bottom-up approach of developing AI will be very, very good than the top-down approach. Because when we really consult these farmers, because all the challenges we are talking about, which AI should solve, the farmers already know. If we are talking about climate change, the farmers are aware of climate change. If we are talking about low levels of irrigation, the farmers know about them. If you are talking about soil degradation, they know them. The question is, how are the farmers solving these problems currently? And how are we going to frame or develop AI models around what they are using now to better their practices in the future? When we try to do that, the farmers will be quick to uptake these technologies rather than use their primitive ways of managing their farms. For instance, they are using agroforestry for climate change. This one economically is very, very viable or beneficial because they don't need more labor. If you look at Agri 4.0, they need high input cost. Initial cost is very high. So how are we going to frame or develop AI models that will go through this system which they are using to cater for the challenges they are going through? And how are we going to make these models more affordable for the farmers to uptake? And these are some of the things. In fact, when I went to northern Nigeria, I saw what they were using to counter these low levels of irrigation. They were using this system called ZI, planting in pits. And this one is something they are doing, and it is working. They are getting the high yields from this. So if we want to deploy AI to maybe counter this kind of practice, it means we have to make it more affordable and more understandable in their own ways. Else, it will be very difficult for these farmers to uptake these technologies. Okay, thank you.
Thank you for that very good insight, and with citing several examples in multiple countries. We appreciate this, and definitely my take home from what you have just said, it's mostly about capacity building, bottom up capacity building, and we really need to demonstrate to these farmers the advantage of using technology compared to their current practices. And of course, we'll demonstrate, of course, the impact, the value, the time cost, the time saving ability of these new technologies compared to, and of course, we have remote early warning systems. So definitely, we thank you for sharing this with us. And Simeon, your hand is up. Let's look into the marine world, the marine economy. Thank you. Smith, over to you, please.
Actually, Ken, I wanted to respond to the point that Ebenezer was making. The situation that you're describing is that there is a disregard for the value of indigenous knowledge systems that exist in the traditional agricultural world of Africa. And I'm not from agriculture, I'm from the maritime industry, I'm from the blue economy. And it is something that we've picked up ourselves when it comes to fisheries and to aquaculture and to coastal and marine tourism aspects. But moreover, you mentioned something regarding the waste tools and the availability of it and the exact suitability of it on the matter at hand. And well, the impression that I'm getting is that the technology that's being pushed towards Africa is operationally inclined. They are not strategic technology tools. In other words, it allows you to remove the operational task out of the mundane task out of operations, but it doesn't give you the ability to have a tool that will guide you strategically on what you need to do after operations is taking place. So I just wanted to understand if I understood you correctly, please.
Yeah, I think you understood me. Yeah, so you know, AI is optimized in a way to solve these two problems: the operational time and strategies. In fact, if you look at the last presentation, I think it covered almost these two. It provided these two solutions. That is the strategy and operational time. So that is it. So going forward, we need to frame our models around how we can create strategies for farmers, because in reality, they don't really have any strategy. They just go into it, farm without any strategy, and get any yield they want. The strategies they are trying to implement are the archaic versions. They are not really helping them, especially when climate is becoming very severe, especially if you go to the Sahelian areas of Africa. These strategies are not really helping them. So, like I was saying, the strategies should be optimized, and the operations should also be optimized to save time and to save cost. When we are able to counter these two challenges, saving time and saving cost, these local farmers have no option than to roll onto these technologies. Thank you.
Thank you. Simeon, I can see your hand again, please, Simeon.
Yeah, at the risk of holding the conversation on the platform at ransom, I just would like to respond to Ebenezer. I think, Ebenezer, that where we are right now in Africa and our relationship with the West, we need to be looking at tapping into more research-oriented opportunities when it comes to this regard, because what we have is an explosion of markets, a boom in opportunities that is becoming available at a higher revenue generating cost, and also a higher potential of gaining earned value for what has been put in the operations. But that is completely dependent on having an effective strategy. So where we would look then at the position of the farmer, you would need to be looking at a comprehensive AI approach towards it that allows them to understand their role in connecting local communities with worldwide markets, giving them the platform to display and to deal, and that I think is not exactly what the current grants is being aimed at. You're going to have to build a case for that and motivate that it is time to walk away from the operational side of AI and embrace the strategic side of AI.
Thank you so much. At this point, I think we really also need to look at the policy and regulatory aspect of this. Do we still cite some challenges based on what we do at the currently, our current services experiences? How could we streamline regulation? Over to you, Angie, please. Angie, your hand is up, so you can go ahead, please. Angie.
Yeah, can you hear me?
Yes, please go ahead.
I'd like actually to share things also from my perspective. So the first thing I think we need to have in terms of collaboration towards having the AI, either technologies or systems, more impactful for the whole ecosystem, is to make sure that we have a systems approach perspective for this. So we need to have the diversified stakeholders aligned, whether we're talking about market players or government or development organizations or even donors. If I'm gonna give like more specific examples on the platform we're developing, like currently, for example, this platform is focused on the Egyptian context. So if you want to make like the collaboration and the impact much more impactful to cover the whole African region, this is not gonna happen without like several partnerships on that, to take the perspective of the wider stakeholders over the African continent when it comes to the areas of categories or signals that they want to see notifications about, the data that they're keen, or the data categories that they're keen to receive notifications about. And not just that, like we also need to include also farmers in the perspective. And I would echo here one of the speakers who discussed the knowledge of farmers. Farmers do have a lot of knowledge, and they are so underestimated. Like we have done a lot of conversations with them and signals mapping, and we like echoed their perspective and the things that they want to receive notifications for. And this needs to keep going and even magnified over the bigger geographic region to cover Africa as a whole and not just Egypt. The challenge from what we have seen would be, and also this echoes a lot of the speakers here, the government. In developing countries, the government and presence of data platform, like those two things are usually not so okay. Like usually governments in developing countries, they feel threatened kind of by presence of data platforms, and they feel that this has to be theirs or this has to be developed by them. So I would say this would remain a challenge that needs to be tackled and focused and discussed. Either how we can include governments in such conversations without having them stopping developing such platforms, or whether it would be better to include their perspective but not include them in the conversation in terms of actual inclusion and actual like licensing and all of that. this is an ongoing conversation that I think needs to have a lot of debate to see what would be the best story in this. And the last thing I would also like to focus on or to highlight is also the role of universities. The role of universities also can be very effective, especially with how this can, like the ongoing or the papers that are being developed at university level, and how this can relate or lead to more impact when it comes to signals mapping and programmatic simulation insights. So also this part of partnership and collaboration needs to be there, especially that for big data futures platforms, sustainability to remain there needs a lot of collaborations and a lot of manpower. So also universities can play a great role in both. Either we're talking about
Hello. Simeon, are you still speaking?
No, I haven't spoken because I was waiting for Angie to finish.
Okay, Angie was still speaking. Angie, I think probably it's network.
Okay. Why don't we give her a chance to respond and let us know whether she's still speaking?
Angie, are you still online? Hello, Angie. Okay.
It seems frozen. Yeah.
Yeah, okay. So, Simeon, probably maybe we can take your question, please.
Yeah, I'm coming from the blue economy, and hence my perspective will always be colored with those lenses. But from where I've seen policies and regulations with regards to the impact of AI, I found that governments still tend to be very uninformed and very disconnected from current research and industry trends in the area. And I believe in the power of research. I'm a researcher myself. And when you discuss something like this, and we are a bunch of Africans from different African countries coming together, and we have some international support, like a university, for example, who's beside us with this, it becomes very a lot easier to look at national systems of knowledge and national systems of innovations, and approach the various committees that are sitting there, especially when it is in an industry that is as rapidly changing as AI. And the element of government reluctance to engage in these areas, it is better to have a hook from what they are already discussing under national systems of innovation, national systems of knowledge, and hook the technology from that perspective. But coming cold on, we have fragmentation in our connectivity infrastructure, how we have fragmentation in our energy infrastructure, and Africans is working from the bottom up. They are working from the point of, we need to be self-sufficient, we need to have our own network, we need to have our own grid that we use off grid from our national systems, and which is exactly an approach that was described before, that we need to utilize from the ground up. But to do that, we need to have research and development relationships in place. And we need to be in a position where we can interchangeably pilot on one another and different networks that comes into play. It's only when people come together in a specific format and focus on the unity of it, coming from all sorts of perspectives of the industry, that I truly think an impact would be made. Otherwise, what's going to happen is this AI is going to grow uncontrollably. Regulations is going to be misaligned on it, and you're going to find exceptional loopholes being created that will benefit a further and a deeper reaction from the international world, and then to make Africa a hot stop for all sorts of activities. In terms of the sustainability roadmap and collaborations that should accompany this, Africa's long gone walk away from the principle of profit maximization being the only operating principle, and the financial ratios being the only ones that count. Africa is looking at different measures of it. So traditional measurements that are operationally inclined, that does not speak to a strategy, and where the strategy is disconnected from the essence of sustainability, are things that are going to get questioned. And I encourage you to review what you have as your own product from that same perspective.
Thank you for your feedback. I really so much appreciate this session. It's been very informative, and looking at various experiences as well. I just have a last question, and this is for Imam. Imam, you have been in this, you're already offering services to farmers using AI.
Yes.
What would you expect to change? What do you see? What challenge do you see that needs immediate solution? Is it from the regulatory? Is it capacity building? Is it what major, just 1 or 2 points, Imam? Thank you.
Yeah, according to our first experience with our customers, the challenge is not really regulations, because when you provide to farmers solution, the government don't care about you. You don't use any irrigation. It's a platform. The farmer will connect, get the recommendation. You don't have a direct relation with the government, so that you are looking for regulations. For us, for our experience, there is no problem with the regulations. The challenge is almost about rights awareness, because as a private sector, I'm a private, I'm not, it is not my mission to raise awareness. The government must have programs to raise awareness, to show the impact of using technology in real life, because we really get a lot of effort, a lot of money, a lot of fun, of budget to raise awareness of farmers, because there, as in all countries, there are 2 types of farming. There is the big farmer. They are paying and don't care about the money, and 80% of the farmer are smallholder farmers. We are not like America, where we have a big area that own to the same farmer. No, we have a very the challenge is the area that are not centralized with the same owner. We have many smallholder farmers. This is the big challenge, because introducing technology to the smallholder farmers is a big effort, is a lot of money. That's why we go for getting money for the big farmers, for the organization, from the government, and the smallholder farmer, we are using them as a data source, so that we can have a return on investment on that. So for me, the biggest challenges is, first, to raise awareness, to the technological tool. This is for us, must be aligned with the farmer culture, the farmer knowledge, the farmer language, and we should be as close as the farmer, so that he can use and trust the solution, because the challenge of not trust is very important.
Okay, finally, Simeon, let's take your, before we finally close, Simeon, please, over to you.
Iman, what I'm gathering from the success of how you deployed, the fact that you're asking $1 per square meter to the farmer, in other words, that this does not become their capital investment. They are merely buying access to a service. I think that is perhaps what AI in Africa needs to be looking at the multiple and variant applications of the same software for different purposes, and the fact that the same could be applied on multiple parties at any given point in time. So perhaps the strategy of directing the solution to a farmer as a capital layout or an investment in his operation is not then showing that much promise, because you're one of positioning it as a service that he can buy at his convenience is shown to be more resilient. Am I correct in my assumption, please?
Imam, I'm sure that question is for you.
Sorry, I didn't get the question. What is the question exactly, please?
When it comes to providing AI services to farmers and how you have deployed, is my assumption correct that you have a higher success ratio in offering yourself as a service to the farmer at his convenience than if you had had a business model where you are positioning your service as an investment by the farmer into the digital tools?
Yeah, if your question is about our business model, yes, he's a service. We have a SaaS platform. So he pay as he go. He will pay, as I said, $1 per 1 hectare per 1 year. Per 1 month. So consequently, he will get services from us, recommendation. This is for the smallholder farmer, but for the big farmers, we are not getting money from that. We are getting money for proposing other additional features like more deep recommendation, like integrated hardware that like recommendation on the drones, that recommendation on advanced features, but we're going to the farmer through these services. Yes.
I understand. Thank you.
Thank you. Thank you. You for the presentations. Thank you for the engagement. Thank you for sharing with us your expectations, your experience, and the way forward. Probably my colleague, Mahmoud, what would you expect next? How we take this forward? Mahmoud, please.
Okay, thank you all for this. From my side, I will send you and all the attendees, even who didn't attend also, the recording of this video. I think we can exchange between each other what we can do as a type of collaboration across African ecosystem and also European ecosystem through the Italian partner too. Yeah. I think we can exchange this knowledge between us and exchange also what we have. As I see, if every one of us have something developed, so if we can make a collaboration between each others, so we can have something new and more collaborative than before. Yeah. So I think
this
is the next step, yeah, in the future.
Thank you so much. And speaking for the African Digital Leadership Innovation Network, in the aspect of leadership, we try as much as possible in these different sectors to understand the challenges, to understand the gaps, which we have discussed today. And another solution which we usually prefer is to see how we could have some kind of a joint project, Pan-African project that addresses the issues which we have discussed today, and how we could innovatively, sustainably position AI in Africa. So we could use this project going forward in solving, alleviating the issue of capacity building, the issue of research, strengthening research collaborations within Africa and with international partners. The regulatory, you also mentioned sometimes the government are uninformed. They have to be informed. So we just need to look at shared public infrastructure. Shared public infrastructure. There's a lot we could really collaborate with the government. They could have some of these tools they don't know is useful for what we've been discussing today. So they also need awareness. So we could use this kind of project to raise awareness in Africa and strengthen the different loops in the value chain. So this is what I think the African Digital Leadership Innovation Network could help to do. We bring in the different partners together, and if you cite some other additional partners that could support this, this initiative, they are also welcomed. And this is not the first time we have been doing this. We've done this in education. We're also doing this currently in tourism, you know, and because it's really very, very, very important to define the next steps. You understand what I'm trying to say? So definitely I'll be coming back to you and to see how we could collaborate on this and take this forward in Africa. Amen. I can see your hand, please.
Yeah, I have a comment on what you said and have a question. The comment is the challenge is having an open platform for free is it should we should think about the budget, how it can reach farmers. The challenge not I will share with you 6 or 5 open platform. I already have. There is many platform open. We have with the FAO, with the World Bank. There is a lot of open platform. They already exist in Tunisia. But the challenge is it should reach the farmer himself. And really, this is a big challenge. Need budget, need effort, need team, need government. I don't know, but we should think about that. This is according to our experience, and the question is, I'm asking to share contacts and discuss further partnership because, as you said before, each one from his side he can he can do what he can. It's sure that if we have consortium, if you have partnership, we will get what we want with a clear vision and the clear goals.
Exactly. And this is how we could help to develop the value chain in Africa. So, and from what we have discussed today, it's very valuable, very informative, and it has opened a lot of questions as well. And of course, we have to think out of the box to bring all these puzzles together to move Africa forward. So, Andriano, we welcome you to join us on this journey, and our European partners to see how we can all work together. Simeon from South Africa, I like our configuration today. We have from North Africa, from South Africa, from West Africa. We understand the different perspectives, the different challenges coming from different regions, and having a kind of a pan-African approach, you know, solving problems at country levels will be a very, very vital tool to move AI forward in Africa. My esteemed speakers, thank you so much for sharing with us today. I thank you for your time. I thank you for what you have shared with us. And we look forward to engaging with you again in the immediate future. Thank you so much. Simeon, you have something to say, Simeon, please?
Yes, before we separate into our own ways, I would like to ask that I can make contact with you guys, or you can reach out to me. As I indicated, I'm involved in a chamber for the blue economy that overspans all 18 activities of the blue economy, and technology is a cross-cutting theme throughout the chamber. The chamber is supported by a blue bank, but for now, I need research relationships in place for the chamber. I need technology relationships in place with chambers, with other providers. I need to have a network that I can ask to come in. One of you, I think it was the gentleman from Ghana, has talked about drones. That is a specific area in the blue economy that we are looking at now for port inspections, as well as AUVs for virtual coast guarding services, because our navies this moment in time are doing a catch and release on crimes that are happening within our EEZs. Then from a technology perspective, we need assistance with aquaculture and marine biotechnology, and we need it fast. We need AI to be a common theme in our operations, not cutting out the ability to conduct it manually as well. So please make contact with me. I do look forward to having an offline conversation with each of you. Have a beautiful day, and thanks for having me. Thanks, Ken. Cheers.
Thank you all so much, and definitely you will hear from me. I'll provide you with some feedback and with a summary of what we have discussed today and the contact of everyone. And definitely let's keep in touch. Thank you so much.
Thank you.
Have a nice day. Bye-bye. Bye, everyone. Bye. Bye.
Bye.
Bye.
Bye-bye. Thank you.
Maybe